Welcome to our lab. Today we will be erupting a volcano, but it's not your ordinary volcano. As you will see, this volcano is a bit more dramatic than the ones you've seen in elementary school. So here's what we're going to do. We will be using hydrogen peroxide, liquid dish soap, yeast, warm water, and food coloring in order to make our lava solution. Hydrogen peroxide can irritate the skin and eyes, so be sure to take proper safety precautions when handling this substance. Always be sure to wear goggles and gloves, and do not ingest or stand over the chemical reaction.
Eek, no gloves!
First, mix our concentrated hydrogen peroxide with a few drops of liquid dish soap and pour it into our volcano. Also add some food coloring to give our lava some color. Then we're going to shake it all up. Next, we mix 3 tablespoons of warm water with our packet of dry yeast. This acts as our catalyst and is added to make the hydrogen peroxide decompose very quickly. As a small amount of hydrogen peroxide generates a large volume of oxygen, the oxygen quickly pushes out of the container. The soapy water traps the oxygen, creating bubbles, and turns into an explosive foam. You can feel the heat coming off the substance, which indicates an exothermic reaction.
Now that we've seen the science, it's time to understand it. Let's take a look at this equation. 2H2O2 goes to 2H2O plus O2. Here we have our decomposition reaction. Decomposition is one substance breaking down into 2 or more products. In this case, we see the hydrogen peroxide that we started with and our 2 products, water and oxygen. But if you're feeling like a few of the things we used in our experiment are missing here, you're right. As we talked about, the soap is there to trap the oxygen, making foam. It doesn't actually react, so we don't consider it a part of the reaction. Next comes, you got it, it's the yeast. Yeast is a catalyst, which means it's a substance that is not consumed or produced by the reaction. Instead, its presence lowers the activation energy of the reaction. The decomposition of hydrogen peroxide is very, very slow. It takes years to break down in any noticeable way without a catalyst to speed things up. That's why household hydrogen peroxide has an expiration date. Eventually, it becomes too diluted by the water produced in the decomposition to be useful anymore. But in our situation, we wanted the reaction to occur, just a little faster, so we added the yeast. This lowers the activation energy required for the reaction to proceed. Let's take a look at these energy diagrams. First is the diagram for the decomposition of hydrogen peroxide. As you can see, the activation energy is very high. Now if we add the catalyst, yeast, the activation energy will be a lot lower. By lowering the activation energy, the yeast allows the reaction to occur much more quickly and dramatically. One other important concept to take away from these diagrams is the direction of the flow of energy. As we can see, as the reaction proceeds, energy is lost. What this means is that the reaction is exothermic. Woo! One way we could tell this when doing our reaction was that the foam gave off a lot of heat. Obviously, we could feel that the air around the foam was warm, but we could also tell that a blown-out splint, when held close to the foam, would relight. That's all from us. Thanks for watching! Hope you enjoyed our Elephant's Toothpaste Volcano.